Good afternoon, everybody. Today we are starting the chemistry complementary course, and this is the third chapter of the chemistry. That is, the title of the topic is nuclear chemistry and radioactivity. So, we know that the nuclear chemistry is the study of the property and changes in the nucleus. And we know that the nucleus is consisting of the proton and neutron, and the whole mass of the atom is concentrated in a very small area, that is the nucleus. And the electron, which is having the negative charge particles, is revolving around the nucleus. So the protons and neutrons are collectively known as nucleons. Now we are moving into how to represent an element. So I have shown an example here, that is the helium. So the atomic number of the helium is 2. That is, in the nucleus I have shown the left hand side the atomic model. The nucleus consisting of the two protons, which is shown by the pink ball, and the charge is represented by the positive, and the neutron is represented by the blue ball, and it is a neutral particle, and the electron is represented by the green ball and having the charge negative, and which is revolving around the nucleus. So for the helium element, it consisting of the two protons, that's why the atomic number is represented by the 2, which is shown in the subscript. And the mass number is the total number of the protons and neutron which is present in the nucleus. I have shown the mass number as 4, which is represented by the superscript. So this is the representation of an element. Now we know that the isotope are having the same atomic number, but only the difference is in the mass number. So here in the left hand side I shows some of the isotope of the hydrogen. The first one is the ordinary hydrogen. The atomic number is 1. That means it contains only one proton having the charge positive. And for the deuterium, the atomic number is again 1, but mass number is 2. So it is represented by H1, atomic number 1, the mass number 2. And only the difference between the ordinary hydrogen and deuterium is it's consisting of an neutron in the nucleus. Next is the tritium. Tritium consisting of one proton. The atomic number is the same, but only the difference is tritium consisting of the two neutron. So the mass number is 3 in the case of tritium. In the right hand side, I have shown some of the isotope of the carbon. The ordinary carbon atom shown by the carbon 6, atomic number 6, the mass number 12. So in every atom, we are representing the atomic number as subscript and mass number as superscript. For the carbon C13, the atomic number is same 6, the mass number is 13. And for carbon 14, the mass number is 14 and atomic number is the same, that is the 6. So for every isotope, the atomic number, that means the number of the number of the proton which is present inside the nucleus is the same. The number of the proton which determine the element. So that is the same. So in every isotope for the carbon, it is 6. And there are large number of the 400, approximately 400 stable isotope are available. And now we are moving into the natural radioactivity. The natural radioactivity was first discovered by the famous scientist Henry Becquerel in 1896, which is an accidental experiment. While we are investigating the uranium salt, Becquerel accidentally discovered radioactivity, and Becquerel found that the photographic plate were fully exposed when in contact with radioactive salt. So how will the radioactivity occurs? So in the normal nucleus, sometimes if the nucleus is unstable, it will liberate its energy in the form of the radiation. Sometime it may be alpha radiation, may be beta radiation, or gamma radiation, and moving into a stable nucleus. That is the natural radioactivity. So we know that the alpha particle, it is the helium nucleus, and beta is the electron flow of electron, and the gamma, it is the electromagnetic radiation. And if you are keeping a radium source inside a lead casing, it will naturally emit the radiation. And if you are applying an electric field, some of the radiation is deviated towards the positive field. So that we call it as beta particle, since it have a negative charge. And some of the radiations is deviating towards the negative electric field, and we call it as alpha particle, and we know that the alpha particle is the helium nucleus. And some of the radiation is not deviating towards the positive and negative charge and go straight towards the photographic plate, and that radiation we call it as gamma rays. Thank you.